I don't put the squared at the end. I put it on the function itself. So what this actually means is sine x cubed. And this means cosine x squared. Now, here's the reason that we do that. Okay? You can probably figure it out. As long as those parentheses are there, there's no confusion. But what if I forgot to put those parentheses in? That could mean two things, right? That could mean the sine of x cubed, or it could mean the sine of x cubed. So to avoid having to use parentheses all the time, we just put the cubed after the sine, or after the cosine. That's where we put our powers. This is what it means, but this saves me from having to put all those parentheses every time. All right, so I want you to take a look at that problem. The directions say simplify. What do you see that can be done? What could I do to this problem? Yes?
Like the 3 and the 2 multiply it? Or
well, they're two separate terms. So you can think of this kind of like a cubed plus ab squared. This is something cubed plus that same thing times another thing squared.
Oh, so you add those two?
These can't add, can they?
They're like those, what's it called? The powers.
Actually, the powers don't add because they're not like terms. Okay? What could I do though? Can you think of something else that you could do?
Sine x of
Did you get rid of the signs?
Okay, when you say get rid of the signs, what do you mean?
Like cancel them out.
Okay, you can't cancel them out, but you can factor them out. So Creighton noticed that there's a sign in this term and a sign in this term. So he said, let's factor them out. So I'm going to pull out one sign. That's all I can factor out because I only have one here. Okay? So what am I left with? If I take a sign out of this, what will I be left with? Sine squared. And if I take a sign out of this, what am I left with? Cosine squared. Stop right there. Somewhere on your notes, up the side or at the top, in big letters, you're going to write sine squared plus cosine squared is 1. What is happening in Blanchett's classes? You're all late.
How we presented.
This is called the fundamental trigonometric identity, and it's a biggie. Okay, so write that down somewhere where you're going to see it and remember it. So, in other words, this parentheses right here is 1. So you have sine times 1, which is just sine. So the directions to the problem said simplify. So we started by factoring because we couldn't think of anything else to do. And we noticed that we had a sign over here and a sign over here, so we pulled it out. And that left us with this, which is a really big deal in trigonometry. Sine squared plus cosine squared is always 1. We're going to run into a few more things we're going to highlight. Okay? All right, let's try the next one. Oh boy. Secant plus 1, secant minus 1 over sine squared.
Cosecant.
Well, I have to be careful because these are two separate parentheses. They're not, it's not like all one big thing.
Could you multiply the
Oh,
sine?
could we multiply these two together? Doesn't this look like a foiling problem? It's a FOIL. We're gonna FOIL it. So what is secant times secant? Secant squared. And remember, we write the squared like that. We put it there, secant squared. Okay, outsides. Minus secant, right? When I multiply. What are insides? Plus secant. And what are last? Minus 1. Well, what do you notice about that? This part cancels out, doesn't it?
Yep.
So all we have left is secant squared minus 1 over sine squared. You know what, I'm gonna have to get another sheet of paper out because we're not gonna have enough room on here to write down all of our important stuff. So get another piece of paper out, we're gonna keep a list of our important identities. Like this is gonna be the first one on the paper, but I think we're gonna give you another one. And at some point, I'll probably give you a big sheet that's got all this on it. But for today, we're just gonna make a list on a piece of paper, and then we're gonna keep this piece of paper handy. Okay. So you already have, write this one down on your paper. I know it's in your notes. Write it down on your piece of paper. This is a biggie. Sine squared plus cosine squared is 1. Always, always, always. Now, I want you to leave a couple lines on your paper under here, and I'm going to give you another one, okay? The one I'm going to give you now, leave some space here, because we may end up writing some other stuff in there. So just leave some space. Down here, your next one is 1 plus tangent squared is secant squared. So this right here is my piece of paper. I've got this written on there, I've left some space, and now I've written this down. Now, underneath this one, I want you to subtract 1 from both sides. If I did minus 1, would you agree that this says tangent squared equals secant squared minus 1?
Do you want to write this down?
Yes, I want you to write this down underneath this one. Are these two the same equation? Yes. They're just written with things rearranged a little bit. Right? But I want you to have both of them written down on your paper. Because this one, this version, is helpful in this problem. What's helpful in this problem? Well, what do you have on the top here? What's secant squared minus 1? Tangent squared? Isn't secant squared minus 1 tangent squared? So now my problem looks like tangent squared over sine squared. Stay with me. Stay with me. You've never done this before in your whole life. This is day 1. It's an exciting day. Now I had to erase it because I don't have much room with the video, but we started with this thing, we FOILed it out, we collected like terms and ended up with this. Then we're using our piece of paper, our identity sheet, we call this is gonna be our identity sheet. And we noticed that secant squared minus 1 was the same as tangent squared. We're not done. I want you to skip some space. And the next thing I want you to write on your paper is that tangent equals sine over cosine. Bet you didn't know that until today. But tangent is sine over cosine. If you divide the sine by the cosine, you will get the tangent every time. Okay, you have that written down? Okay, so this guy right here, tangent squared, is sine squared over cosine squared. That's this. And that is over sine squared. So I am rewriting my tangent as sine over cosine. Right now, you're just trying to follow along. I'm 63. I've done this for 50 years. You're not where I'm at yet. You're just following along. You'll get it. You'll get to be better at this than I am. You'll get it. Just takes a while. Now, would you agree that this, it's a big giant fraction, but is it really a division problem?
No.
Yes, it is. It's a division problem. It's sine squared over cosine squared divided by sine squared. This is the numerator divided by the denominator. So it's this fraction divided by sine squared. Now, how do I divide when fractions are involved? What do I have to do when I'm dividing by fractions?
Can I ask you where we at? She's haven't read it, buddy.
We are on problem number, what are we on, problem number 2? We're on problem number 2.
Okay.
Wait, so is that part like not the problem? The part on the right?
The one that's
What you wrote down.
These things are written on my formula sheet.
Okay.
These are the things I've written on my formula sheet.
Okay.
This is the problem here. And there was some more of the problem, but I erased it in the very beginning. So I heard somebody say it. What do I do when I have division of fractions? I multiply by the reciprocal. So I'm going to multiply by 1 over sine squared. And since this is a multiply problem, won't these cancel out? So what am I left with? 1 over cosine squared? Which is absolutely perfect, but I might even give you a bonus point if you recognize what's 1 over cosine?
Cosine -1?
No, it's a good guess, but no.
Sine squared?
What's the reciprocal of the cosine? Secant. So this is the same as secant squared. Now, you don't have to do that. It's perfectly okay to leave it right here. But if you recognize, oh my gosh, I've got 1 over cosine, and 1 over cosine is secant, because they are reciprocals of each other. Oh my gosh, that's a huge problem. That is huge. Now, I am gonna have to erase all, you have all this written down on your paper, right? All these things, okay. Is Now we're on to the next problem. Alright, so let's look at the next problem. And again, you're just beginners, so it's okay. You really should be able to look at this and think of something to do. You should be able to think of something to do with this problem. So don't get bogged down in all the letters and all that. What do we have? We have a fraction minus another fraction. How do we do a fraction minus a fraction? Common denominator. So you gotta just stand back, get past all the yickiness of the problem. You basically have a fraction minus a fraction. Okay? So our common denominator will be those two pieces. Our common denominator will be 1 minus sine times cosine. That's my common denominator. The common denominator is both pieces. Now, this one already has the 1 minus sine part, so it needs just the cosine part. So I'm going to multiply top and bottom by cosine. Now, does it have the common denominator? Yep. Now, what about this one? This one already has the cosine, but he needs the 1 minus sine part. Do both fractions now have the same denominator?
Yeah.
Yes. Don't get bogged down by the order. It's multiplication, so the order doesn't matter. Okay? So now they have the same denominator, we can go ahead and combine them. So we have cosine squared, cosine times cosine. Now be careful here. You're going to take minus sine times 1. So won't that just be minus sine? And then minus sine times minus sine, because we're doing a distribute.
Yeah.
What's minus sine times minus sine? Positive sine squared. So once again, this is a distribute. It's negative sine times 1 and negative sine times negative sine. Now I want you to look at that numerator, and I want you to look at your piece of notebook paper, and you need to see something. What do you see? Makes my heart sick.
Equals 1.
There's a 1 in the numerator, because don't we have a cosine squared plus a sine squared? They're not next to each other, but don't we have it?
Yeah.
So that makes 1. So now I have 1 minus sine. This is the 1 minus the sine over 1 minus sine cosine. Oh boy. Can I cancel that out? I sure can, as long as I cancel the whole thing. So what am I left with? Well, I'm left with cosine on the bottom,
So
right?
1.
So 1 over cosine, which is full credit, 100% smiley face, yay raw. But a bonus if you recognize that 1 over cosine is secant. Because it is. Secant is the reciprocal of cosine, so 1 over cosine is secant. So let's take a second look at that problem before we move on. Make sure you're following what we're doing. Hi, what's on me? Why do you have so much stuff? Yeah, there we go. Okay, so first thing we did was get a common denominator. And how did we know we should get a common denominator? Because we had two fractions to subtract, right? So we got our common denominator. We did some distributing and noticed we had 1. Well, as soon as we made that 1, we noticed, oh gosh, it cancels out, and we're done with the problem. Okay? All right. Number 4. Cotangent over cosecant. Would you agree, and this might not occur to you to do, but just go with me here for a minute. Would you agree this means cotangent divided by cosecant? If that's what that problem means?
Yeah.
Okay. Now, I want you to look at your formula sheet there. And on that formula sheet, you said that tangent was sine over cosine. So what will cotangent be? Cosine over sine. How do we know that? Because tangent and cotangent are reciprocals. So on your sheet, write cotangent x equals cosine over sine. So are you good with that? Does that kind of make sense to you? If you trust me that tangent is sine over cosine, then cotangent has to be cosine over sine. So that's what I'm going to do here. I'm going to make this cosine over sine. One little technical point. When I write this on the board, when I say it, I'm saying cosine over sine, but when you write it, you have to put the x there. I don't always say cosine x, sine x, but you have to have the x's there when you write it down. I will take off points if you don't have the x's. Gotta have them. Okay, I'm good with that. So that's divided by, all right, what is cosecant? You know this. Cosecant is the reciprocal of the reciprocal of the sine. So this is the same as 1 over sine, isn't it? That's on your original colored sheet. They are reciprocals of each other. So now I've written my problem. I made this into a fraction and I made this into a fraction, but it's a divide. So what do? Multiply by the reciprocal, and it's the reciprocal of the second one. So it's cosine over sine times sine over 1. What happens? The signs cancel, and I will be left with just cosine. So the direction said simplify, and that one simplifies down to just cosine. All right. Having done that one, look at the next one. It looks very similar, doesn't it? It's cosecant theta over secant theta. Now, if you don't like theta, it's fine, make it an X. Or make it a Y, or make it an A. Doesn't matter. Now, whatever you make that one, you have to make this one the same thing. You can't call that X and that Y, but as long as they're the same, the variable doesn't matter. Remember when you're solving equations, it doesn't matter if you use an N or an X or an A, same thing here. Use whatever it is. Taking a clue from the last problem, is this a division? Is this cosecant divided by secant?
Yeah.
So let's write it that way. And then let's change these guys into fractions. What is cosecant? Well, it's the reciprocal of the sine, so it's 1 over sine. Cosecant is 1 over sine. And secant is 1 over cosine. Okay, so what do we do at this point now? We've written them as fractions. So we're going to multiply by the reciprocal of the second one. So it's going to be 1 over sine times cosine over 1. Oh, shoot. Last time we could cancel, now we can't. So we just multiply straight across, and what do we end up with? Cosine over sine, which is, no, cosine over sine isn't 1. Cosine over sine is cotangent. Right? It's gonna get easier, I promise. It's never gonna be easy, but it's gonna get easier. Now I got the hiccups.
Did we scare you?
I don't think that works.
If you hold your breath.
I get the hiccups way more than a normal person does. All right. Cosine squared over 1 minus sine. Now, a minute ago, on your piece of paper, I had you write the main identity, the big one, the big identity. And later, I will give you a whole page of these crazy identities. But the big one is sine squared plus cosine squared is 1. That's the biggie. However, that can appear in various forms. For example, if you took this equation and you subtracted sine squared from both sides, what would this look like if you subtracted sine squared from both sides? What would it say? Cosine squared equals 1 minus sine squared? Okay, remember when I had you leave some space under this? I want you to write that in that space. And I also want you to write this in that space. Because couldn't I subtract cosine squared and end up with the same sort of thing? So this is already written on your paper. And now these two are written underneath it. These three things are all the same equation. I've just written them in different orders. Please do not think you have to memorize 3 separate things. You don't. You memorize this one. And then if you need to rearrange things, subtract sine squared, subtract cosine squared, and you get these versions. That's on your formula sheet, yes. These two are written right under this one. I told you to leave some space, I hope you did. They're written right under that one. This part you don't have to have, I was just showing you what I was doing. Now, I want you to look at the problem that we have. Nothing cancels. Your job is to simplify this, and not a thing can cancel in this problem. However, what do we know about cosine squared? What does cosine squared equal? 1 minus sine squared. Now that's a fact. Cosine squared equals 1 minus sine squared, always and forever. You still can't cancel, because these minuses screw everything up. You have to be able to factor before you can cancel. So I want you to look carefully at the numerator. It actually factors. Does anybody see it? Do you remember something like that? How does something like that factor?
Squared.
A minus b, a plus b. It's called the difference of squares. So anytime you have a square minus a square, you can factor it into a minus b, a plus b. Now, is 1 a square? 1 squared. This is obviously a square. So that numerator is 1 minus sine, 1 plus sine. A minus b, a plus b. 1 sine. 1 minus sine, 1 plus sine. Now, boys and girls, can I cancel? Yes. And the answer to the problem is 1 plus sine. That's all that's left. Just 1 plus sine.
So where did you get the 1 minus sine?
Cosine squared
Okay.
is 1 minus sine squared.
Oh, okay.
I substituted it in.
Okay.
And I did that, Matthew, because in order to simplify this, I have to be able to cancel, and I needed signs on the top. Yep,
Okay, so
to make it happen. I know what you're thinking, oh, when is she ever gonna shut up? I'm not. We have a lot of problems to do. So here we go. Okay, Sean? Oh, no, I just want you to pay attention.
Oh, I
Sit
know.
there with your head down.
I'm trying to.
Try real hard.
Yeah.
Okay. So we get on with this problem. This is our next problem. Can I factor? Is this a factorable problem? No, because nothing matches. If this had been a sign, then I could factor, right? Because I'd have a sign on both sides. But as it stands, nothing factors. So I want you to look at your formula sheet there. Is there anything you can see that I could do here? I have to do something. Okay, so Matthew says, I don't have any squares, so none of that's gonna work. But I do know that tangent is sine over cosine. Now, when I wrote this sign, I put it over 1. You don't have to do that, but I like when I'm gonna multiply by a fraction, it helps me to put it over 1, but you don't have to. Sine is sine over 1, tangent is sine over cosine. Now, when I times these, nothing cancels. When I times them, I get sine squared over cosine. Would you agree with that? And that's still plus cosine. That. Now, pretend you're all by yourself, sitting at your dining room table or wherever you do your homework. You're all by yourself, and you have to fight your way through this.
Go to that Ford video.
What do you think? What do you think you would do next? Okay. Don't we need to add these two fractions together, you guys? And to add them together, we'll need to get a common denominator. And the common denominator, this one has a cosine, this one has a 1. So cosine is the common denominator. So this one has it already. This is sine squared over cosine. He's good. This one needs a cosine. So remember, you have to multiply the top and the bottom. So that's going to be cosine squared over cosine. Don't cancel that because it'll take you right back to where you started. You put that cosine down there so that you can add these together. Oh, are they addable now? They have the same denominator. So we're going to have cosine on the bottom, that's our denominator. And then, are you getting excited? On top, you have sine squared plus cosine squared, which is 1. So we're right back to where we were a little while ago. 1 over cosine, 100%. But you want that bonus, you're going to recognize that 1 over cosine is secant. Life is good.
You know what I mean?
Mrs. Ford, how did you know to change the tangent into sine over cosine? Quite honestly, kids, there's nothing else to do. I can't factor, I can't add, so the only thing we could think of to do is change that tangent. And then I had fractions and could get a common denominator, and then I knew where to go from there. But in the beginning, a lot of times you should take a stab at it. A kid in the honors class the other day said, is it sort of like throwing stuff at the wall and seeing what sticks? Yeah. You just try something, and sometimes it works and sometimes it doesn't. All right, next. Cotangent sine plus tangent cosine. All right, I want you to look at that. Do they add together? No, they are not like terms. All the rules that Mrs. Field taught you back when you were freshmen, they still apply. You can't add them unless they're the same, and they're not the same. So, what's your thought? Change these guys. This is what? What's cotangent?
1 over tangent.
Well, it's 1 over tangent. What else is it? Cosine over sine. So I'll change this guy into cosine over sine. And he's times sine over 1. These two are multiplied. Plus, now I'll do the same thing with my tangent. Creighton, are you feeling okay, sweetie?
Yeah, I know.
Okay, well sit up and keep your eyes open then. If you need to go to the nurse or something, just say the word, all right? So tangent is sine over cosine. And he's being times by cosine over 1. Agree? Right, now, you have this plus this. So let's just look at this one for a second. Is there anything you can do with that one? Yeah, cancel, right? So all of that is just cosine?
Yep.
And then what about over here? That would just be plus sine.
Tangent.
Now, be careful, it's not cosine over sine or anything like that, it's cosine plus sine. That is not 1. To make it a 1, they have to be squared. When they're not squared, they're nothing, they're cosine plus sine. That's it. You can't do anything else, you've simplified it. So look at what you started with though, that's a mess. And you boiled it down and it just turns out to be sine plus cosine. That wasn't too hard. Number 9. Okay, look at your formula sheet and see if anything pops out at you. See this parentheses here, guys? Look at your formula sheet. Do you see that on there?
Yeah.
What does it say about 1 plus tangent squared? It's secant squared. So this is cosine times secant squared. Now, tell me about secant. What is secant? Secant is the reciprocal of the cosine?
Yeah.
So isn't secant squared the same as 1 over cosine squared?
Yeah.
If you need to write on your paper that 1 over cosine equals secant, then write that down. So you recognize when you have a secant, you're going to think of it as 1 over cosine. And if it's squared, it's going to be 1 over cosine squared. Now, what do you notice? This is a multiply problem, guys. Don't get a common denominator, you're multiplying. We only get common denominators when we add or subtract. Can't you cancel? No. Yeah. And if I take out a cosine, all I have left on the top is a 1, and all I have left on the bottom is the other cosine. There it is again. 1 over cosine is secant. So this is full credit, that's a bonus point for being smart. Would you take a second or two and see if you can figure out what to do with this? And I'll give you a hint. Think of it as tangent squared divided by secant squared. See what you can do with that. Start with that and see what you can do while I put in my attendance. Don't talk, just do it. No ideas?
Okay, well, I
Not a single person had an idea, even,
I don't, but I think so much take it back to the sense, because doesn't, secant squared x, won't that just be, 1 plus tangent?
it absolutely
And
is.
same thing with tangent, it's supposed to be secant squared minus 1, but don't just take it back.
Yeah. So changing both of them wouldn't really accomplish much,
No.
but you could change either one of them into the other. The problem is gonna be, you still can't cancel, because there's gonna be a plus or a minus, depending on which way you changed it. You see what I'm saying?
Yeah.
So you could make this, let's see, 1 plus tangent squared is secant squared. So I could make this tangent squared over 1 plus tangent squared, and that's awesome, but these aren't gonna cancel because of that guy right there. So that's why I think this is the way to go. So I'm gonna leave them what they are, and I'm gonna think of it as a division problem. Now, did anybody change tangent squared into sine over cosine? So this would be sine squared over cosine squared, right? Divided by, what did we say secant was?
1 over cosine.
1 over cosine squared, in this case, because of the squared. So now we changed tangent into sine over cosine, and we changed secant into 1 over cosine. You still with me?
Yes.
All right, they're divided. This is a division. So what are we gonna do? Multiply by the reciprocal. So sine squared over cosine squared times cosine squared over 1. Now it's a times problem, so won't these cancel?
Yeah.
And what are we left with as our final answer? Sine squared.
Ms. Ford, is there a possible way for like somebody to like make the problem and end up being like dang near the same problem as the problem that you just got?
As the original, you mean?
Uh-huh.
You mean to simplify this
Yeah.
and get something that looks a lot like it? Sure. There are thousands of these combinations we can come up with. Okay, we're gonna do a few more. I know you're excited. All right, number 11. Let's do the same thing. Let's pause for a moment and see if you can think of anything. Pretend you're on your own and you have to do something. Look at this problem and tell me what you think you might want to try. You should be looking maybe at the very first problem we did today. Look back at the very first problem. What was the first step of the very first problem?
Oh, taking off the sign.
Taking out the signs. That's what Kai says. Taking out the signs. Can I take out the signs on this problem?
Yeah.
Yes.
Actually, I can take out sine squared, right? Don't they both have a sine squared?
Yes.
So let's see what's left if we pull out the sine squared. I'm factoring. So I'm pulling out the sine squared. So what will I have left? Secant squared minus 1. Remember, when you take out the whole thing, you have to leave a 1. Right? Okay. Okay. Now I'm looking on my sheet. and there's something on my sheet that says 1 plus tangent squared equals secant squared. What does it say right under that? I think I had you write something right under that. What does it say right under that? Did you write something right under it?
Tangent squared equals secant.
Oh, tangent squared equals secant squared minus 1. So wait a minute. What's in this parentheses right here?
The tangent.
Isn't this tangent squared? Did you use your sheet to help you substitute stuff in? Rewrite stuff? This is tangent squared, so now I have sine squared times tangent squared. Well, what's tangent squared? Please don't say secant squared minus 1, because that would just take us back to where we were. What's another way to think about tangent? Sine over cosine. So what if I wrote this as sine squared over 1 times sine squared over cosine squared? Would that be legit?
Yes.
All good? Oh, Cradola, nothing cancels. I was hoping something would cancel, but it doesn't. What am I left with when I multiply straight across? Sine to the 4th over cosine squared? And you are done. There's not a darn thing you're going to be able to do with that. So my friends, we're going to do one more problem. You've been really good. Really good. I really appreciate your attention. One more and I'll stop. Okay, one more. Number 12. Here we go. Do I see you tomorrow? Oh, crap. I don't see you until Tuesday then?
Yes.
So you have 3 whole days with no math, no homework, no nothing.
So sad.
I'll be on video in case you get lonely. All right, here we go. Take a look at it. Do not cancel. Kids, you can never cancel when you have pluses and minuses unless you can cancel the whole thing. Okay, so we had a problem a minute ago where we had a secant minus 1 over a secant minus 1 times a cosine or something like that. That will cancel because you can cancel the whole thing. But if you can't cancel the whole thing, then you can't cancel. So I want you to look closely at that. Do you notice anything about the numerator? We've already talked about it today. Exactly. The numerator is the difference of squares. Isn't this a square and this is a square? So how will that factor? Cosine minus 2, cosine plus 2. Take the square root minus the square root and the square root plus the square root. That's how we factor the difference of squares. And all that's over cosine minus 2. Now what can happen? Now you can cancel because you're canceling out the whole parentheses. Not just a piece of it, but the whole thing. So the answer to the problem is cosine plus 2. All right, you deserve a break.